These are the notes about similar figures, proportions, and scale factors. When you come to class next, if you weren't here on the day we talked about these, there is a handout. It has a lot of this written down. You just need to fill in the blanks, so you might want to pick one of those up. Similar figures are figures that have the same shape, but they're not necessarily the same size. Might be, might not be. The symbol for similar is a squiggle line. It's that symbol that has highlighted right there. Not equal to, but similar to. What we mean by similar is that they look the same, but one is small, one is large, possibly. For two similar, or polygons to be similar, what you're going to find is that their corresponding angles have exactly the same measure, so they're congruent. And that's what gives them the same shape. But the lengths of their sides are proportional. I will tell you, it's like a scale model of a car. Probably some of you have put together model cars or model airplanes, boats. On the side of the box, there'll be a scale factor, and it will say for every 1 inch on the model, it represents 3 feet on the actual car or boat or airplane. So that is what we call about being proportional. There is a multiplier that you can use to get from the smaller figure to the bigger figure. So our goals in this activity is, 1, to be able to identify similar figures, to know why they are similar, why they're not, match up the pairs of corresponding angles and corresponding sides, and then to be able to find missing measurements for similar figures when some of the measurements are missing. All right, first example, let's see if we can at least identify parts, okay? 2 figures are given to you. You can see that the one on the right is smaller than the one on the left. And if you will match up congruent angles, the angle here N has 1 arc and T has 1 arc, you can see that the figure has also been turned sideways. So that will help you look at it. We need to identify the congruent angles, the proportional sides. We'll write a similarity statement and then what's called an extended proportion. So let's start with the pairs of congruent angles. If we match up by the markings, you can see that N and T have a single arc in them. So we know that angle N is congruent to angle T. Angle P has double arcs and so does Q. So P and Q are congruent. Now they have told us that these figures are congruent. So it looks like we're walking around the first figure up and over. So we're going to angle O, which is the next one in our list. And in the figure on the right, we're also going up and over that way. So the angle that matches with it is R. And then finally come on around to the last angles, and that means that angle M and angle S are in corresponding positions. So they are congruent angles. Walk around the figure. You can start at any vertex, but walk around the figures and match them up. Then the sides. All right, NP is between a single and a double arc. The side between a single and a double arc and the other figure is TQ. So those two are similar. PO is the next side and we're walking around the figure. So it is similar to QR. You just walk your way around the figure. OM is similar to RS. And then MN and ST. They are in corresponding positions. They are similar, and we will write ratios with them. They're proportional. Lots of different words go with these. The similarity statement is this one up here for part C that I've already written. What that means is to name the figures and make sure that you have the names written in an order so that corresponding sides and corresponding angles are in the same position. So with the first name, you can start at any of the 4 vertices. I chose to start with N, and I walk around the picture. So NPOM. For the second one, you have to make sure that you are writing the corresponding angles in the same order as they were in the first picture. So since N and T are in corresponding positions, we start with T. P corresponds with Q, so that's next in the name. O corresponds with R, and then M corresponds with S. And we can see that in the name, corresponding angles are in corresponding positions. If you write that name first, you'll be able to get the sides of the angles from that name, and that's called a similarity statement. It says one polygon is similar to another polygon. And then the next thing is the extended proportion. Okay, we're going to take this apart in bits. We're writing ratios of the lengths of the corresponding sides. So that's step 1. Take each of the sides. I'm going to go the figure on the left over the measurements from the figure on the right. You just decide an order and you stick with that order. So the length from N to P over the length from T to Q. That will be in the same ratio as PO to QR and OM to RS and MN to ST. If we actually had numbers, if we would write those ratios of corresponding sides and reduce them all, what you're going to find is that they are equal. So we wrote the fractions, those are the ratios. When you set the fractions equal, you have a proportion, and since we have more than 2, we have several ratios, that's why it's called an extended proportion. And like usual, pause this video at any time if you need a little more time to write things down. So once we know the ratios of the sides, that thing is called a similarity ratio. It's a ratio of the sides, corresponding sides in similar figures. And that's usually what we call it in geometry or in any math class, especially if you're going to do calculations with it. In real life, we like to talk about real life. If you were to look on the side of the box of a model car, you're not going to see the word similarity ratio. You're going to see the word scale factor. They're exactly the same thing. Scale factor is the ratio of the corresponding linear measurements, means the sides, of 2 similar figures. So, in the 2 figures that you have in front of you right now, the ratio of the sides AD and HI. So we're doing the side on the left to the sides of figures on the right. So the ratio of the lengths of AD to HI is AD over HI. AD is 8 long, HI is 12, and if we reduce it by dividing both numbers by 4, we get 2/3. That's a similarity ratio. Usually when you say ratio, even though it can be written as a fraction or with colon or with the word 2, when we say ratio, you're usually going to write it like a fraction. The scale factor of AD to HI with original numbers is 8 to 12. But remember, we always reduce everything. So the scale factor is 2 to 3. And whenever you see anything on the side of the box, you're not going to see a fraction. You're going to see something with a colon or something with the words TO, 2, TO, 3. They all mean the same thing. Means for every 2 inches in the figure on the left, the figure on the right will have 3 inches. We can use those scale factors to find the lengths of missing parts. We'll do that in just a minute though. For right now, let's see if we understand what it means to be similar. Again, let me refresh you. I'm going to write it down again. You want to make sure you have this written down somewhere. There are 2 conditions for polygons to be similar. The first condition, corresponding angles must be congruent. If it passes that test, Then you want to check and see if corresponding sides are proportional. Those are the two, whoops, AL. Those are the two conditions to be similar. And we're going to check that out on the problems that come next. All right, let's start with the first one. It says determine if they're similar. So first I'm going to check out the angles. I'm going to check to see this one goes 1 arc, 2 arcs, 1 arc, 2 arcs as we go around the figure. The other figure, 1 arc, 2 arcs, 1 arc, 2 arcs. So it's telling us that the single arcs are the same measure, the double arcs are the same measure, they're in the same pattern. So it looks like it passes that first test. The next thing we need to check is to see if corresponding sides are proportional. So if I look at MN, it's a 3. And that goes from a double arc to a single arc. Here's a double arc to a single arc. So that is a 4.5. But when you write these ratios, it's one figure on the left, over something from the figure on the right. And then we're going to check and see if all of them are in the same proportion. So keep walking around the figure. 3 to 4.5, 3 to 4.5, 3 to 4.5. All of those ratios are the same, so it passes the test. So the two figures are similar. Now we need to write a similarity statement. Write the name of one of them in any order. So MNOP is similar to, find an angle that marches with M, that's U, and walk around the polygon, URST. Double check to make sure that corresponding angles are in corresponding positions. They are. And this is our similarity statement. For the scale factor, take those ratios that you wrote. Everybody remembers you can't mix decimals and fractions, so I'm going to do a little fancy footwork. If I take both of these multiplied by 10, I'm going to move that decimal over, and then I can reduce my fraction by dividing by 15. I get the fraction 2 over 3, so my scale factor is 2 to 3. I need to pause here. We'll come back and there'll be a second video that starts with the next example shortly.